Okay, so I'm going to try to be quick, and hopefully I do it. But I'm going to tell you about a platform that we've been working on in the CSIR, and we call it the Visual Surveying Platform, or VSP for short. So today I'm going to basically tell you just very quickly about our mechatronics perspective to problem solving, and just so you understand how we look at solving problems. Then I'll give you an overview of infrastructure platforms being developed in the CSIR in general for different areas. Then we'll look at specifically for road infrastructure and the need that's associated with it, and then our mechatronics response to it. Then we'll look at the VSP itself and its different modes of operation. We'll look at a use case scenario, and then a little bit of theory on image processing, not much. And then some work that we're doing on some surveys, and then some future work. Okay, so first, mechatronics. So mechatronics is an integration of mechanical, electrical, and computer engineering, and a bit of mathematics thrown in the middle. So it's an integration of these different skill sets, and we use this combination to try to solve problems. So in a nutshell, this is what our hammer looks like. So infrastructure specifically, there's a number of these projects and platforms in the CSIR dealing with energy management, water quality management. We've started up some stuff on pipeline inspection and railway inspection. And today I'm going to show you specifically the road infrastructure platforms. Okay, so for road infrastructure, defects in the roads is a global problem. It's not just a local one. So these are little newspaper clippings from around the world. And no matter how much some countries might lie about the road infrastructure problems, they actually do exist. Oh, sorry. Yeah. Okay. It's a little bit of a joke. So our response to the whole thing is we decided to build an integrated vision-based system to manage and maintain a road infrastructure. So the idea is to make a video of the road and analyze the video, roughly. And we thought that we could aim this at different types of road defects, like potholes, cracks, road markings, and road signs. So this is what we built, and this was the first thing that we aimed for, which was to build an autonomous version of this visual surveying platform. And the way that it works is we've got a sensor which is mounted onto a tow bar on a vehicle, and you switch it on and drive the road, and it collects video of the road, different types of defects. Then you can download the video onto a computer, and the computer runs some analysis software. And in this mode, which we called autonomous mode, the detection and the estimation of the defects are done automatically. So there's some algorithms which runs on that analysis software, which detects the defect, and then it determines the size of the defect. Then it takes that detection and puts it into a database. And from the database, there's another screen on the same piece of software which allows you to visualize what's in the database. So you basically see a map with little tags on it, and you click on any of the tags, it'll show you a little picture of what's there and some properties about it, like size and volume and so on. From the same piece of software, you could select little tags, generate a job card, and the idea was that you hand those little PDF job cards in printed form to a repair team, and they go off and fix them. After that, we realized that we achieved a certain accuracy with regard to the detection and estimation with the autonomous mode, and we found that there was always a need for putting the human back in the loop. So we developed another mode as part of the same system, which allows a human operator to watch the video stream, and the human replaces the algorithm that does the detection. So the person watches the video screen and just clicks on something that he thinks is a defect. Then the defect gets automatically sized, and the detection information is put into the database, and you can use the visualization tool again. So we call this thing manual mode, and this is one of the modes that we've actually have out in the field being trialed by a few external companies. Then we created a hybrid mode, something semi-autonomous, something in between. So what happens is the unit does an automated detection by watching the video stream. The algorithm picks out what a defect is, and then it makes a suggestion or a recommendation to the human operator. And the human operator just does a validation. He just basically says, yes, it is a defect of that type or not. And then the data is put into the database and visualization can happen. So those are the three main modes of the VSP. We think, since we built it, even though we were somewhat ambitious in the early days and we went straight for the autonomous mode, we managed to get an 89% detection rate on the autonomous mode in terms of detection accuracy. But and most of the errors were related to false positives, and that's why the validation was required. But so going forward, we keep the autonomous mode as part of our research, and whatever new algorithms we develop in the autonomous mode, from the research, we feed it back into the hybrid and manual modes, and those are the actual products that we hand out to external clients. This picture is a very simplified diagram of a use case scenario of using VSP. So what we see over here, over on the top line, is a general simplified workflow for one of the municipalities in Johannesburg. We discussed it with them, so that's how we got this. And this is highly simplified, but calls or reports come in from either the public or from these apps that they have available, and those reports go to a call center. The call center operators put that into a more formalized report and feed it through the financial management system, so the right departments get billed for the work. From there, actual works orders are handed to repair teams and they go off and fix them. Now, VSP, which is the system I just described to you, we figured we'd put it into a vehicle with a human operator doing the validation. So this is the hybrid mode that we had in mind. As soon as, so the operator and the driver drive around in a vehicle somewhat like this, and they do the validation. As soon as the validation is done, a report associated with the validated detection is generated. The report gets sent straight to that call center database, and the call center operators make a formal report, put it into the financial management system, and hand it to repair teams. We can also then visualize information that's being passed through this line. So this is what we thought was the simplest way to actually deploy the unit in an existing municipality. Now, as we go forward, so we proposed this to one of the municipalities in Johannesburg, and and we are probably going to deploy this scenario there. Now, as we move forward and learn more about their systems, these reports, there's potential to feed these reports straight into the financial management system. And if the validation operations that happen there are transferred to this operator here, who's sitting in the vehicle, then these reports could go straight to the repair teams. And as we move forward, if that becomes a reality, then this pipeline from here to the repair teams becomes the fastest pipeline through the entire system. Okay, this slide just shows a little bit of some of the image processing and background processing that's being done. So there's a bit of data preparation, there's some pre-prep processing, which is basically some filtering and color space segmentation. Then there's some clustering, which is part of the detection algorithms. And then the real detector actually happens with some a sequence of neural networks which does some classification for us, and then we use some camera-based triangulation, calibrated cameras, to actually do the estimation itself. I can give you more details on this if you'd like, but later. In terms of going forward, even though we focus on certain specific type of defects for now, it can be extended to others. For example, cracks, and we've had lots of requests come in for road signs because apparently there isn't a system for that. And the system could be also applied for runways and rail inspection as well. So, but for now we'll focus on the road until we perfect it. We've also developed the software on the system so that it could actually accept inputs from a number of other existing systems. So for example, you could call this the gold standard in pavement measurement systems. Now this is just one example of a vehicle like that, but there's a few others, but from other companies, but they basically have the same kind of idea. And they're pretty expensive. So typically you don't have too many of them, and the implication of that is that it's low. With a vehicle like that, you're going to have low frequency and low coverage of updates. Mobile applications, they do exist, and these are becoming really popular. Lots of people these days have got little dash cams, and this specific dash cam has a GPS built into it. So we could use that data and pull that into our system and populate maps using that. This is our system, by the way. This is the VSP attached to the back of a vehicle. So the VSP doesn't exactly intend to or aim to replace these state-of-the-art high-precision instruments. The VSP is supposed to actually create a first-level estimate of what your environment looks like by making use of the fact that it can do it at a higher frequency and a higher level of coverage, simply because you could put many more of them out there. Okay, this here is some of the analytics that we do. So since the first version, we've moved past detecting roads and road defects, and we've also developed some algorithms on detecting road signs. So I'll show you some videos of that just now. This is a visualization screen, so it's, just so you can see what the tags look like. So the tags appear on the map, and you can plot routes that you want to be included in the job card. You can also do a bit of validation on this from the same interface as well. So road repair is the obvious thing that you could do to try to use this as part of a municipality's workflow, but you could also do a significant amount of trend analysis once you accumulate all of the data. And you could then create value-added data and send that back down to consumers as well as clients. This shows a bit of a survey that we've been running ourselves in the Pretoria East region. So if you click any of these tags, they are actual potholes that look like that. So this is out in the top end of Pretoria, so that's Delmas Road there, I think. Yeah. So thanks. Okay, this slide here, basically where we're going next with this. So everything I showed you so far is contained in those two little blocks there. Going forward, we'd like to pull that information. So you would have distributed instances of this blocks at different clients. So we would like to pull all that information from multiple clients to a central backend, integrate all of the information, and then add value and send it back. Now to do that, we thought that we would create a data analytics engine at the back end, and that'll be hardware, some system management software, and then some algorithms, and this is our main interest, to further process the information that comes from there. Once we drew this picture, it also becomes quite clear that there's existing technologies in the CSIR which already can fulfill the purpose of some of these blocks. So many of the CSR engineers have been talking about how you could integrate VSP with some of their systems that currently exist. Okay, so this here is just a video that just shows a bit of the automated detection. So this was the first one that we did, right? So automated detection of potholes. So it does have some false positives, and that's what we try to filter after this process. But this is just a visualization to show you what this looks like. And I'll stop this one. This one is for road signs, so there'll be a blue square around each of the detections whenever it happens. So let's just watch maybe a few more. Yeah, so that's the road sign detection algorithm running. And that's my presentation. Thank you.